Okay, hello everyone, and welcome to another Identity in 15 session powered by WSO2 Identity Server. So in today's session, I'm going to go over how you can secure your OAuth2 tokens using DPoP, which is an extension on top of OAuth, which allows you to bind the tokens you get to the client itself. So, a quick introduction about myself. I am Chamath. I'm an engineer at the Identity and Access Management team of WSO2. And let's get into it. So, for the agenda today, I will first go over the application layer proof of possession specification and what it actually does. And then we'll see how you can build the DPoP extension and add it to the WSO2 Identity Server. So, and then we'll see how we can generate DPoP tokens in the client side, and we'll see how everything falls into place in a demonstration. Okay. So first, before we move on, if you guys have any questions, clarifications to be made, please add them down in the Zoom chat. And after the session is finished, I will take them. So to start, proof of possession. So as you may know, OAuth2 tokens are typically known as bearer tokens. So how it works is you have certain, OAuth is used in many scenarios. You can have it in web applications, devices, smart devices, so on and so forth. So basically what we call as a client. So what happens is the client will send a request to the authorization server to get an access token. So it would authenticate themselves at the authorization server, and the authorization server would verify their credentials and send back an token. And then the client would send this token to a resource server and gain access to resources that this access token is granted for. The problem with the bearer tokens is that if an attacker gets hold of this access token, they can portray to be the owner of the access token which it was originally minted for, and gain access to these resources and privileges that are there granted along with the token. So to counter this, we have bound tokens. In a bound token, what happens is when the client is sending the token request to the authorization server, the client would send something of themselves, sort of like a DNA. In most cases, this would be the public key, which is in the client side, and the authorization server would bind the public key to the token and send it back to the client. So now the access token itself would have something that was owned by the client embedded into itself. So when the client goes to the resource server to access a resource presenting this access token, the resource server can then challenge the client to prove that he is actually the owner of this access token. So that is how basically we would mitigate any replay attacks if the token is stolen. Alright, so this is the proof of possession flow overview. The client would have a private key and a public key. And first, the client would request a token from the identity provider. And in that request, the client should send something of himself, like the public key. And the identity provider would bind that public key into the token and send it back to the client. And next, when the client wants to access a resource in the resource server, the client would first send the token. Client would send the token it obtained from the identity provider, and along with that, to prove that this public key, he's the owner, he has ownership of this token, they would also send to prove something of a proof. So the proof in this case would be like a signature. So how this signature is generated is the client would feed in the private key and the message body into a sign-in algorithm, and that it would generate the signature, and the signature element also would get attached to the API request that is sent to the resource server. Now the resource server would have two entities that it can validate this request with. First, it would validate the token by calling to the introspect endpoint of the identity provider, and then it would validate the signature with its public key, and finally the resource server would validate the public key and the binding to the token, and then send back, if it's valid, then it would honor the request and send back a response. So this is the basic proof of position overview. And we have quite a few proof of position options, like mutual TLS, which is most popular one. We have client sessions. Now the latest addition is the application layer proof of position, which is by the DPoP specification. So application layer proof of position is particularly useful in single page applications when you have public clients. So it's gaining more traction. With in WSO2 Identity Server, we don't have support out of the box for DPoP token binding, since it actually this spec is currently at a draft state. So we provide it as an extension, so you can install the extension and use the DPoP token binding. We will get into that part in the demonstration. Next, I will go over the basic DPoP flow. First, we have three entities: the client, authorization server, and the resource server. The client would send a token request, and along with that, client would send something called the DPoP proof JWT, which includes the public key of the client. And the authorization server would extract the public key and compute its thumbprint and embed that into the token. Actually, it gets embedded in the CNF claim, and we get this DPoP bound access token sent back to the client. And when the client wants to access a resource, it would send this DPoP bound access token, and along with that, they would also need to send another DPoP proof JWT. And what the resource server would do is it would first validate the access token, validate the signature of the JWT in the DPoP proof JWT. This is actually JWT, and then it would validate the binding between the token and the DPoP proof. And if it's valid, it would honor the request. So that's the basic DPoP flow. Now we'll see how you can install DPoP extension on WSO2 Identity Server and use the DPoP binding in your authorization flows. So we currently have this in a separate extension in WSO2 extensions identity auth add-ons repo. We have a component called Carbon Identity DPoP. I have linked it in the description. So first, what we would do is we'll clone this repo. So if you go to this component in the README file, you can actually see all the instructions. I will keep a copy of this. So first, we'll look at how to deploy. So it's asking us to build the Maven, build the product using Maven. So to do that, I will first clone this. After I clone this, I can go into the root folder and go to the DPoP component and build it using Maven. So you need to have Maven 3.6 or above and Java 8 or above to install it. Run the command. Okay, so it's it got build. The artifacts can be found at the target folder. I will go to the target folder and do so this is the artifact that we should be getting. So the next step, as per the readme file, is to copy this artifact into the is home repository components drop-ins folder. So currently don't have any is instance running. I will be using Identity Server 5.11 for this demonstration. First I will unzip Identity Server zip file distribution. After that we can copy the artifact into the drop-ins folder. So I will go to the drop-ins folder, repository components drop-ins, copy the path and copy the drop-ins and copy the artifact into our drop-ins folder. Okay, now that is done. So the next step is to add these configurations into the deployment toml file. So I'll copy this and open up the deployment toml file. It's in repository conf directory. Okay, I have pasted it now and I will save the file, deployment toml file. Now we can start the server. I go to the bin directory and start the WSO2 server instance. Okay, while this is getting started, if you have any questions so far, please feel free to ask them in the chat. And I have linked some resources in the description which you can go through to understand the DPoP flow a bit more precisely, more in depth. And you can go to our Identity in 15 YouTube page and go over our previous videos that we have covered similar integrations and authentication flows. Okay. So after this is getting after the server gets started, the next step is to configure the service providers. So if you already have a service provider, you can follow this path. I'll be creating a service provider myself anew because we just had the deployment. Okay, I'll go to and open the service providers, click on add, create a new service provider, and next I'll go to the inbound authentication configurations and open up the OpenID Connect configurations and click on configure. I'll add a dummy callback URL because we won't be using this mostly. The important part is the access token binding type. So we need to set it to DPoP based binding, and we need to check this validate token bindings checkbox as well. That's all we have to do. I mean, if you already have an application, you might see this, you will see these configurations in this configuration page. You need to set it according to this. Now I'll click on add. Okay, so now we have done all the configurations for the identity server side. Next up, to initiate the request, we need to first, when we are initiating the token request, so I'll be using Postman for this. We need to send something called the DPoP proof JWT. So according to the specification, we need to create a JWT ourselves. So the client has to create the DPoP proof JWT, and it should look something similar to this. So I already have a client to generate the JWTs. I have linked it in the description also. It's in this repository. I already have it open. So I will go over to the code and explain what is happening. So we have this RSA key pair generator. So what it does is generates a private key and a public key pair. So I will first run this one. This would be used to create the JWT and sign the JWT. Next up, this is the DPoP JWT proof generator. So as per the specification, we need to set the type in the header. We need to set it to DPoP plus JWT. So in the header, I have added that, and I added the RSA public key that we all generated just now. And in the payload, we need to set these few claims. We need to add the JTI, which is the token ID, and there's this HTTM claim, which denotes the HTTP method that we are using when we are sending the request, and then HTU denotes the HTTP URL of the request that we are sending, and then there's the issued at time claim. So I'm generating the JWT DPoP proof JWT for the token request first. So I will execute this script, and here I will select token endpoint, and it would get saved to this DPoP proof JWT text. I will go over to jwt.io and show how this would look. So we have the type in the header and the key, and we have the HTTP method post HTTP URL as the token endpoint, should at time, and the token ID. Alright, so since we have this thing done, go to Postman and first send the so here we need to set authorization type. I will set basic auth, and we'll provide the client ID and the client secret of the service provider that we just created. And in the headers, we need to add a new header called DPoP, and we need to pass the value that we generated now. So this might be expired by now, so I will run it again and generate a new token. It should be saved in the file. So I'll copy this, paste it in the DPoP header, and everything looks good. I'll send the request. Okay, so now we get the access token. First, we will introspect the access token to check the binding type is correct. So to do that, I will call the OAuth2 introspect endpoint. At the value, I set the token. The authorization header should be admin. Yeah, this looks good. Okay, so we get the introspect response, and we have the binding type as DPoP. So now, since we have gotten the access token, next up we'll see how we can access a resource using this DPoP bound access token. So to access the resource, also we need to send the DPoP header in our request, and the authorization header should have the DPoP says the access token. So I'll paste the access token here, and we'll need to generate a new DPoP proof JWT to access this endpoint. So this, note that this method is get and the URL is kim2 users endpoint. So in the code I have that as the resource URL and the resource HTTP method. So I'll run this again and set the profile to resource endpoint. Now our DPoP proof JWT is created. Copy it and paste it here. Okay, this looks good. I'll send the request. Right, so we get a response with all the scheme 2 users that we have. So that's basically it for the demo. So now if we were to change anything in the DPoP proof, like if you were to change some of the parameters, then the signature validation would obviously fail. And if someone sent a request that is not for this endpoint and added the DPoP proof from an earlier request, then also it would fail. So we have that validation in place as well. Okay guys, so that's all I have for today. If there are any questions, I will go over them now. If you have anything, please add them in the Zoom chat. Okay, seems like there are no questions. So if you follow this later and if you stumble upon something, you can always reach out to us in our Slack channel, which we have linked in the description. And also please follow the IAM community Twitter account to get the latest updates for our developments. So that's it guys, thanks a lot. We'll see you in the next Identity in 15 session. Thank you.